guess you already know what machine learning is, so I don't have to give an introduction about that. The internet, you probably also know what that is, because we're using it right now. I'm not sure the DNS did. Do you know, guys, what that is? Did you ever register a domain name yourself, for example? Perhaps I can see a few hands to have some feeling about the crowd. Okay, I see some hands. Okay, that's cool. I already expected that because we have a technical crowd here. I'll now start sharing my screen, and that also means that I cannot see you anymore. So if you do have a question during the presentation, you have to unmute yourself, I guess. Otherwise, you have to wait until the end of the presentation. So yeah, I work at SIDN Labs, the research team of the .nl operator. And today I will give you some background about SIDN itself. So what do we do as a company? But I will also talk about the labs department, the research department of our company. And then I will make the move towards machine learning. So what are the topics that we're working on regarding machine learning? And I will also introduce two projects that we work on. So one project is about detecting fake web shops, and the other one is about detecting abusive web pages via logo detection. So some of you already did it, but suppose you want to register a domain name. What do? Then you contact a registrar. So that's a company like TransIP, GoDaddy, MijnDomein. And there you can register a domain name yourself or on behalf of a company. But that is not only happening at the registrar. If you pay some amount of money, then the request is sent to a TLD operator. And SIDN is the TLD, top-level domain operator of the .nl zone. So what do? If you register a domain name, then we make sure that domain name is added to the DNS zone of .nl. So we do the registration of .nl domain names, and in total there are 6.2 .nl domain names. That's quite a large zone for such a small country. But what we also do is we make sure that you can actually use those domain names. So what does that mean? The DNS system, the domain name system, that is basically used to translate names, domain names, that you can easily remember into IP addresses that computers need to communicate, but are pretty hard to remember. So what do? For every transaction, so for every time you use a domain name, then we are almost always involved in the process of resolving, translating a domain name into an IP address. So to give you an estimate, that results in 2.5 billion DNS queries that we have to process every day. And a large part of them we also store in a Hadoop environment so that we can also do analysis on that. For example, to check whether we need to improve our systems, but also to do data analysis, for example, to detect abusive domain names. And apart from these two major tasks that we have as a TLD operator, we do a lot of more things. So we invest in open source projects. We also have a fund, SIDN Fonds, that does a lot of investments in open source projects, but also in startups that are working on a better internet. And we have a research team, and that's the SIDN Labs team, and that's the team that I'm working for. We have about 12 people in this team, and there are also a few students that do an internship at our team. And the goal of our team is to do research that helps to increase the trustworthiness of the infrastructure of the internet. And we do that in particular for .nl and the Netherlands. But as you know, the internet, the DNS is not limited by the Netherlands. So often we also collaborate and work together with parties outside the Netherlands. And we're a technical group, so we're in between universities and operational teams. So we do a lot of applied research, so measurements, prototyping, doing evaluation studies, these kind of things. And we try to be as open as possible about the things that we do. So we publish a lot of code, but also statistics on our website, blogs, sometimes papers as well. And we also try to work with other parties as well, so universities, network operators, and other TLDs in Europe or in the world. So there are a couple of areas that we're most interested in. one area is called network security. So that's about the core protocols of the internet. So the DNS, NTP, which about time, but also protocols relating to routing. So Anycast and BGP. We also have some people who work on the security of domain names and IoT devices. And some of us work on future internet infrastructure. So not the protocols that we use today for communication, but the ones that might become popular in the future. So now let's make the step to machine learning. So that's the topic that I work on, together with two colleagues who also spend half of their time on machine learning. So the goal of machine learning here is also to increase the security of the internet. And why do we use machine learning? Well, there are a lot of data sets within the internet. So for example, within SIDN itself, there is the registration database, but we also have the logs that I mentioned of these authoritative name servers. We have crawlers. There's a lot of data, and there's really a lot of value in this data, but it's difficult to come up with patterns. So that's our use case for using machine learning. And what we do, we try to explore and integrate ideas that we find on the internet, that we find in papers or during talks like this, and we try to use those insights to come up with prototypes ourselves. So what we don't do, we don't try to compete with large research groups at universities or at companies like Google or whatever. So what we basically try to do is we try to innovate with machine learning, but we don't try to innovate in the field itself. But I guess for you, perhaps the same holds. So this is why and what we do on a very high level, but we also try to do it in a responsible way. And I'm very curious what you think about this, because I think responsible machine learning, responsible AI is a very important topic, and I think we as data scientists do have a responsibility there. But it's also difficult or challenging to go from like the high-level ideas to something that you can adopt during your day-to-day work. So I will give you some bullets, some ideas on how I try to be responsible in my work, but I'm very curious on how you see this in practice. So one of the things that we try to do, we always try to have a human in the loop. So that means, for example, that we have not only for the machine learning projects, but for all the research projects that we have, there is a privacy board, which is sort of a ethical board where you have to write a proposal, answer some questions about what you want to do, what data you want to use. And this board consists of employees of SIDN with different backgrounds. So there is a legal person, there's a commercial guy, there is someone who is on the support desk, and those people, they analyze your idea, and then you can get some questions back. And I think that really helps to strengthen your proposal, but also to be transparent about what you do and what you don't do in your projects. Another thing is that we don't use our algorithms to make automatic decisions. So it's only used as sort of an insight, but not used directly to act upon domain names. So for example, we give suggestions or notifications about suspicious domain names, but we never take down a domain name only based on a machine learning prediction. And we often also implement sort of a feedback loop. So the labels that we get back from our analysts, we use that to retrain our model from time to time. Usually it's not a thing that we do immediately, so it's not an automatic process, but once every month or so, then we just do a new batch and we retrain the whole thing. So that's one thing that we try to do, try to have the human in the loop. And also I'm a big fan of using simple models, not only because they are more efficient, but also because you have less chance of making mistakes. And you have the advantage of explaining your insights to analysts or people who are using the models or the predictions. So I have a strong preference for those kind of models. And what we also try to do is try to collaborate with other parties and to publish. So here are two examples, and those projects, I will also talk about them in more detail during the rest of the presentation. So what we do, we publish blogs and we publish papers, and we also do a lot of pilots or projects with other parties who can provide extra data or help annotate or do part of the research. Another thing that we do is, of course, we try to monitor the performance of our models. And a big problem that I experience, and I guess you experience the same challenges, is how to monitor your model during production. So if you don't have your labels, then of course you can have some heuristics, but it's always a challenge to sort of spot when you have to retrain or when your model is making too much mistakes. So that's also a thing that we try to focus on a lot. So for the high-level overview of what SIDN does, what role machine learning plays within this organization. Now it's time to talk about two projects that we're working on. So one is on fake webshop detection, and the other one is on detecting logos with a bad motive. So here on the slide, what you see, it is a web shop, nederlandwebshop.nl. And as you can see, this web shop, it's well designed. There are some popular brands out there. The domain name, it looks trustworthy, and there are discounts. So I guess if you want to buy a jacket or shoes, then you might want to buy something here. But I can tell you this web shop is fake. So if you buy something here, nothing will be delivered, or a lower fake quality version of the project that you see on this slide will be delivered. So in other words, if you buy something on the web shop that I just showed, you will be scammed. And that's a problem, because if you got scammed, then you experience losses, and those losses, they have been reported in the media a lot, as you can see on this slide as well. And for SIDN, for the maintainer of the .nl zone, that's a problem, because we want to keep .nl safe for consumers. So a few years ago, we thought, can we do something about this problem? Yes, we can, because we have the perfect vantage point. As being the TLD operator, we have the list, like I said, of all .nl domain names, but we not only have that, we also have registration data, so some information about the people who registered the domain name. But we also conduct crawling, so active measurements, for example, on the DNS, about TLS, so what kind of web certificates are being used. But we also check what kind of email servers are being configured, so SMTP crawls. And we also do web crawling, so basically HTTP crawling. And another type of data source that we have, and that's very useful in this case, is the Entrada data set. So that's the historical traffic that we observed by our name servers, so all the DNS queries that we see. So what we did in this project, well, we achieved quite a lot. So we detected thousands of fake web shops, and by doing so, we also protected users from being scammed. So that's really cool that we had some impact in the real world, so to say. We also wrote an academic paper about this project, where we focused on two detection systems and two case studies that we did. So one involved brand counter, and the other one is fade. Today I will not talk about brand counter, because it's a bit old, and also I think a bit too simple for you, because that detection system, it's only focused on the HTML titles. So what we did is we drafted a list of suspicious words that we observed in fake web shops, and we then just counted the number of suspicious words. And if there were too many suspicious words, then we flagged that domain name and send it to an analyst. And that is very simple, but it did work for a while. But then eventually the people behind those fake web shops, I think they just recognized our method. So they became smarter. So we had to come up with a more clever method of detecting fake web shops. So what did we do? We started to collaborate with ICS Card. That's a popular credit card provider, issuer in the Netherlands. And they provided us with a list of web shops that were actually involved in scams. So they were reported by their customers. And we used that data set as a ground truth data. And then we just started with a simple classification model to classify between, on the one hand, suspicious domain names, and on the other hand, legitimate domain names. And it's important here that for this project, we didn't want to use HTTP, so web content, web data, because we found it out that the crooks were, they recognized that we're using HTML data, etc. So we wanted to use different features in this project. So here's the pipeline. So the of this project, it's very basic machine learning pipeline. So we have this data set, the counterfeit domain names that were reported, and we also sampled an equal amount of legitimate domain names. Then we came up with a couple of features. So we used only features related to the registration. So for example, the email provider that the registrant used, or the hour of registration. And we also used some features that were related to the infrastructure of the domain name. So for example, we checked whether TLS was used or whether an email server was configured. Then we did the basic splitting of training and testing, and we trained a model to our data set. And then we found out that it worked very well on this relatively small data set. But at least it was for us sufficient to continue with this project. So what we did is we applied it to the .nl zone. We applied it to 30K .nl domain names. And there we found out that a little bit over 1.4K domain names were classified as suspicious. Those domain names, we sent them to ICS Cars, who did an annotation study. And of those suspicious domain names, it turned out that 73%, almost just under 900 domain names, were true positives. So they were indeed malicious. And of course, we didn't stop here, because finding out that something is malicious, well, it's not enough. We also wanted to take down those domain names. So what did we do? We sent notifications to registrars with the question whether they were willing to remove those domain names. And the majority of those domain names, they were indeed taken down. So 84% of the domain names were taken down. And you can see that also on the plot. So that's the true positive bar. The blue part were the ones that were taken down, and the orange ones are the ones that were not taken down. And in addition to notifying those registrars and taking the domain names down, we also took a step back and tried to see how the counterfeiters operate. So what are the strategies behind the people that register fake web shops? And in our paper, there are a lot of more insights, but here I just want to show you two graphs. So on the left side, you see the time between a domain name that became available again. So a lot of domain names, they are being canceled. So somebody doesn't have interest anymore in a domain name and cancels his subscription. And then after a few days, the domain name becomes available again. And what we see here is that the crooks, the people who register fake web shops, they tend to register domain names immediately when they become available. So after 1 day, you see that 60% of the domain names is already registered. After 10 days, about 90% of the domain names are registered by counterfeiters. So what we observed here is that there's probably a lot of automation involved. So they just query our systems and wait for a domain name to become available. And that automation, we also see that on the web pages. So there are a lot of templates that are being reused with just a couple of changes here and there. And what we also found out is that a lot of the registrations, it seems that they come from China. So if we look at the hour of registrations, you see that on the right plot. Then on the x-axis, you see the hour of registration. On the top, the time zone in Amsterdam, and on the bottom, the time zone in Beijing, China. And the y-axis contains the number of suspicious domain names. And what you see is that the majority of the domain names are registered during working hours in Beijing. And you can even see a lunch dip during 11 o'clock in Beijing and 4 o'clock in Amsterdam. There is a dip of domain names that are being registered. So this and some other data that gives us, well, strong indications that those domain names were registered from China. So to summarize this project, what did we learn? Well, we learned that it was possible to use machine learning to detect fake web shops, but we also learned that it was very important to collaborate with registrars and also ICS, because ICS, for example, could provide us with ground truth data and help us annotate, but the registrars, we need them to actually have impact in the real world, because we as SIDN cannot take domain names down ourselves, and registrars sometimes can. We also find out that you don't need a very complex system, so the rule-based systems used to work for a couple of months, and then for a couple of years already, the fake system, the machine learning-based system works. Although we did have to change that system a couple of times, so now we're using different features than I just presented, and also the algorithm changed a bit over time. And what we also see is that the number of fake web shops is decreasing. So in 2018, we took down 12K fake web shops. In 2019, were a little bit over 4K, and last year we took down 481 domain names. So that could, of course, mean different things. It could be that our model is not good anymore. It could also mean that the fake web shop owners are starting to do new things, or we have to come up with a new system or a new way to detect suspicious domain names. And that's one of the things that we started to do. So we started a new project. That project is not about the text that we find on web pages. It's not about the infrastructure. It's about the visuals. So the things that you can actually see on a web page. Here I have two examples. So the left example is an example of a phishing page, and the right example is a screenshot of, again, a fake web shop. What you can observe here is that those malicious web pages, they use logos. So the phishing page, it uses the Rijksoverheid, the government logo, and the fake web shop has some logos from, for example, Trustpilot and also banks. So this gives us the feeling that it's a good way to find out malicious web pages by using logos. So that's the goal of this project. We try to help analysts find suspect domain names, suspect websites by incorporating logo detection. And this project, it consists on a high level of 3 steps. So the first thing that we do is we crawl.nl domain names, and we take screenshots. But as I already told you, there are 6.2 million domain names. So taking screenshots of all those web pages, it takes a lot of time, because you have to load all the resources, you have to render the web page. It's taking a lot of time. So we have to be efficient. So we came up with a method to skip duplicates. So what we do is we first only gather the HTML page without all the resources and without rendering the page. And then we create kind of a fingerprint of the HTML. And then we see whether there are duplicates. And then if there is a duplicate, then we only scan a domain name a single time. So that saves us a lot of time. And then we have screenshots, but then you need to analyze them, of course, and we use an object detection algorithm for that. The algorithm that we used is based on YOLO, you only look once, and it should be flexible because the logos that people use, that adversaries use, they can differ. So, for example, a few years ago, the logo of PostNL or other organizations that deliver packages at your house, they were not often used in scams. But during the Corona crisis, those companies, they were a lot of times being used in scams. So, for example, we saw an increase of phishing pages that were using the PostNL logo. So we want to be, it should be possible to add new logos from time to time. And if we want to add logos, we don't want to do the training ourselves. So we want some automatic system for that. So then we have screenshot. We have an algorithm that can detect logos, but then of course you also need to present the logos to an analyst who can use it during his or her work. So we also came up with an annotation dashboard, and this dashboard is quite generic. So it's built for a single organization, but we can deploy it multiple times for different organizations. So currently we're running a pilot together with the Rijksoverheid, with the government, but also with GGD Gohor, but we also have a dashboard for thuiswinkel.org. So to zoom in a bit on the training part, as I mentioned, we don't want to do the training ourselves. So we came up with a simple method to do automatic training. So what we do was we selected a sample of random screenshot, and we have our logo, and then we're just pasting that logo on different positions on the web page. And by doing so, we know where the position is. So we have our ground truth data. And of course, we do some sampling here. So sometimes we change the logo a bit or the screenshot a bit to have a more to try to have a model that better generalizes. And this works really well. So it's very fast. We can generate 48 data points per second. And on a whole outset that we generated ourselves and annotated ourselves, we get a precision and recall of around 98%. So that's pretty good. And currently we use this method to come up with an object detection model that's able to classify, to identify 16 different logos. So those are, well, the government logo, like I said, the logo of PostNL, but also financial institutes, basically the logos that are often used in phishing attacks. I can also show you the dashboard that we created. So it's a basic dashboard where you have a list of results, where there is some metadata that analysts can use for annotation. And of course, you can also filter. That's on the left top part of the screenshot. You can filter or you can update multiple entries at the same time. And if you click on a single row, then there will be another window that's opened. And here you can see some more details and the screenshot itself. So this is basically all the information that an analyst needs to do an annotation. And then they can, for example, do a label. So they can use, for example, say a logo is being used in the correct way or in an incorrect way. And they can also give a status, add a status. So for example, it should be taken down or something like that. So during the last months, we built these systems, and what we do now is we evaluate it. And there the research question is really, it's a cool system. It works from a technical perspective, but can it really help to boost the internet security? So for that, we do two studies. We have a study together with Thuiswinkel Waarborg. So that's an accreditation schema that's being used on many web shops within the Netherlands. And what we try to do here is we try to combine two lists. So there is a member list of all the domain names, all the shops that are allowed to add the Thuiswinkel Waarborg logo on their website. And we have our system that can detect the Thuiswinkel logo. What we basically try to do here is to come up with a join. And then we are interested in the domain names that do show the Thuiswinkel logo, but are not on the member list. And we think that those shops, they have something to hide because they want to look trustworthy while they're not allowed to do so. So we're in the process of running this pilot. It's out of scope for this presentation because I don't have results yet. But another pilot that we're doing, we have some more results there. So that's together with the government. Here we apply the model to our domain names, and what we try to do is we try to detect abusive domains, but we also try to detect domain names that are not known. So the government has a list of domain names that they're using, but it could of course be that there are also government domain names that the central government is not aware of. So to give you the results of the study, here's the slide of the number of domain names that we detected per label. And I will go through this graph from the right to the left. So we start from with a no logo. Well, those are the domain names that we detected. So where our model thought there was a government logo present, but in fact there was no logo there. In 1K of the cases, this was the case. So this results in a precision of 89%, which is pretty good. But of course, yeah, we could also use a different threshold for the confidence and then come up with a different number. So it's, yeah, we tweak the system to come up with this precision, so it works. That's cool. Then there are a lot of domain names that use the government logo, but that's not a problem. So that's a benign web page. But there are, of course, also abusive web pages that misuse the government logo. There we distinguish between high priority cases and low priority cases. So in total, we detected 78 abusive domain names. But there are also domain names that are from the government. So they communicate on behalf of the government, but they are not in the central list, in the central registry portfolio of government domain names. And we detected over 200 domain names that are probably from the government. So this is not an assessment we made ourselves, but that's something that the government did for us. And that's actually quite a lot. So the absolute numbers are perhaps not very high, but if you take a look at the total set of government domain names, that's 2,1271. So then the ones that we discovered make up 20% of the domain names in the government's portfolio. So that's quite a lot. So here I can give you some examples of abusive web pages that we detected. So on the left, you see a clear case of a phishing web page. This is targeted to the Belastingdienst, so our tax agency. And on the right side, you see a lower priority abusive case. So here, there are Snell tests are being advertised for Corona. But the problem here is that it says that the government accepted this product. So it says overheid goedgekeurd, which is not the case. So this is not a very high priority abusive page, but still it's not something that the government wants because it's misleading users. And then the importance of having an accurate domain name portfolio. So why do you want to be aware of all the domain names that you have within your company? Well, for one reason, because if you're not aware of a domain name, then it might be canceled by accident, and then it can result in data leakage. On the right side, there's an example of a data leakage that was resulted by a domain name that was canceled by accident. And also, if you are aware of a domain name, then you probably are the registrant yourself as being a company. And it also means that you have full control over the domain name and the records of a domain name. So then you don't have the risk of, for example, an employee that got fired and registered the domain name on its own name and then got angry and is going to do nasty things. That's another reason why you don't want, why you do want to have an accurate portfolio. And the final thing is that if you are aware of your domain names, then you can also monitor them. So what you can do is, for example, monitor whether security standards or open technologies, whether they are adopted on your web page. And that is especially important for the government, because there is a pas toe of leg uit lijst, which basically means that the government has to adopt certain security standards. And if they don't do, they have to come up with a very good explanation. And of course, for the government, it's very difficult to monitor whether they're doing the right thing if you're not aware of your domain names. So this is a work in progress, but I will give you a slide of why this is important. So what you see here is the percentage of domain names that use DNSSEC. And DNSSEC is a technology that is used to verify the integrity of answers that you get from DNS servers. So you can use DNSSEC to be sure that the answer that you get is true, is a true answer. And what you see here on this slide is on the bottom that the domain names that are already in the portfolio within the list of government domain names, they score very well in respect to DNS adoption. So the majority of those domain names, they use DNSSEC. However, if you look at the newly discovered or likely government domain names, then the adoption of DNSSEC is not that great. So there are still around 20% of the domain names that don't use DNSSEC there. So by adding them to the portfolio, the people at the government can start to monitor them, can start to implement DNSSEC on those domain names as well. And the same holds for IPv6. So here you can see the domain names that have published a Quad A record, so where the web server is available via IPv6. And here you see a similar pattern. So for domain names already in the portfolio, almost the half of the domain names is available via IPv6. But for domain names that are newly discovered or likely government domain names, this percentage is a bit lower. So what did we learn in this project to conclude? Well, we learned that it's useful to focus on visual aspects of web pages, and it can help to detect abuse. It can also help to keep your domain name portfolio accurate. So that's not something that we came up with initially, but it's something that's turned out to be very useful as well. And what we also found out is there's a very large gray area of unwanted, but not per se abusive content. So it's something that you don't want to have on the internet, but it's really difficult to come up with grounds to take such a domain name down. Well, that's not really a technical debate, but it's something that the technology started that discussion within SIDN, within the government, within other organizations. So the next step here is what we want to do. We want to focus on new registrations. So instead of applying the model to the full .nl zone, we just want to check new domain name registrations, because our intuition is that we might discover phishing attacks there more frequently. And we're also writing a paper about this project, and we're planning, or at least it's an idea, to publish the code. So that's perhaps also a question to you guys, whether you think this is interesting to publish as open source code, because we're willing to do so, but it's also something that takes some time. So I'm really open to hear your opinion about that. And that concludes my slide. I hope you find it interesting. And I also hope that you have some nice questions for me. And otherwise, we can go straight to the drinks.